Hi students, this is AJ sir. Let's study 9th standard ICSE Math, exercise 6E. Now we shall study word problems of simultaneous equations. Let's start with question 2. Two numbers are in the ratio 4:7. Now we can solve this using only one variable. We could assume that the two numbers are 4x and 7x, but in this chapter let's use two variables everywhere and solve via simultaneous equations. So always two conditions will be given so that we can get two equations in two variables, and solving them simultaneously will give us the required answers. So here we assume the two numbers to be x and y. The ratio is given, so cross multiply and get equation number 1. Note that y is a bigger number here and x is a smaller one. So since in the question they have said thrice the larger be added to twice the smaller, the sum is 59. So translating this English sentence into mathematical equation sometimes is challenging, but once you get the right equations, then half the battle is won. Then you simply have to solve them simultaneously, which we have trained in exercises 6a, b, c, d, and get the two values of x and y. Make sure you write the final statement in every sum, and you have to solve the equation simultaneously and show all the calculations. I am now going to teach you simply how to make the equations reading the word problems. Make sure you just don't copy the answers. You'll need training in the solving part as well. Now in the fourth sum of two positive numbers is x and y, and the difference of their squares is 720. They have mentioned that x is greater than y. So the two equations are x plus y is equal to 50 and x square minus y square is equal to 720. We can use a formula out here. X square minus y square is x plus y, x minus y. We've expanded them. Now out of that we know the value of x plus y. So let's substitute that and get the value of x minus y. So we got equation number 2. Now solve these two equations simultaneously by any method of your choice and get the answers. Don't forget to write the final statement, otherwise we lose marks. In the sixth sum, again two conditions are given. The difference between two positive numbers x and y is 4. Note that x is greater, so the first equation will be x minus y is equal to 4. And the difference between their reciprocals is 4 upon 21. Now this is a positive fraction, so again this will be positive fraction, the bigger fraction minus a smaller fraction. So there the second equation will have to be 1 upon y minus 1 upon x. You see, if x is greater than y, then 1 upon y will be greater than 1 upon x. We need to keep this in mind, otherwise our answer will be wrong. Now we could do an LCM out here, but the denominator will be xy. I don't prefer that. Rather, what I'll do is I'll use the substitution method. I will assume the x to be 4 plus y, that is equation 1. Substitute that value of x out here. So I've eliminated x, and now the entire equation is in terms of y. Do LCM, that is into 4 plus y into 4 plus y into y into y. Get the common denominator. There is no way to escape the fact that it will be a quadratic equation. 4 and 4 got cancelled, that's good, and then the reciprocal, we get the quadratic equation. We'll split the middle term such that the two terms coefficients when multiplied gives us the constant value. 7 minus 3 is plus 4, okay. 7 into minus 3 is minus 21, okay. So this splitting is correct. You have to be careful about the signs as well. Take y common, get a bracket. Take minus 3 common, get the same bracket. Note here minus became plus because minus is common out. Again, the bracket is same, so take it out common and the remaining in another bracket. This is how we solve a quadratic equation. So either y is minus 7, the sign changes when it goes to the other side, or y is plus 3. But in the question they have mentioned that they are positive numbers. That means y is not equal to minus 7, y is equal to 3. Now substitute this value in equation number 1 once again, so that we get the value of x as well. And please write the final answer. 8th sum belongs to the type called fraction sums. Two conditions are given. Numerator is increased by 2 and denominator is decreased by 1. Then it becomes 2 upon 3. And if the numerator is increased by 1 and denominator is increased by 2, it becomes 1 upon 3. Find the fraction. So let the fraction be x upon y. We always have to write this opening statement, such opening statements. Now there are two cases, and I prefer solving such sums in a tabular method. So in case 1, numerator has been increased, denominator is decreased. So that's a new fraction, and they said that this is equal to 2 upon 3. Similarly, in case 2, these are the new numerators and denominators. The new fraction, they said, is equal to 1 upon 3. So I got two equations here. We have to cross multiply these two equations to get two new equations, equation 1 and 2, and then solve them simultaneously to get the values of x and y. Don't forget to write the final statement, that is a fraction. The original fraction is 2 upon 7. Now in the 9th sum, again it's a fraction sum, but it's simpler. The sum of numerator and denominator is 7, so that's x plus y is equal to 7. That's the first equation. But the second equation, to get that, we'll have to read the question carefully. 4 times the numerator is 8 less than 5 times the denominator. So 4 times the numerator is means equal to 8 less than 5 times the denominator. So now rearrange the terms and get the second equation, solve them simultaneously, get the values of x and y, and write the final statement, which is the fraction is 3 upon 4. Don't forget that. And show all the calculations. Now the 12th sum is a 2-digit number type of sum. In such a sum, we always assume the tens digit as a variable and units digit as another variable, let's say x and y, and the number is not xy, rather 10x plus y. Let me give an example. If the tens digit was 3 and the units digit was 5, you would say that the 2-digit number is 35. But if you write xy, that is a multiplication, x into y. Rather, this is 30 plus 5, 35. So that's 10 times the tens digit plus 1 time the units digit. So this is the standard way we will write a 2-digit number in all sums. 10x plus y. 10 into 3 plus 1 into 5 gives you 35. And in the question they have said, in one condition, what if the digits are reversed? So if the digits are reversed, so this is, let's say 5 and this is 3, the number is 53. How? 10 times 5, that is 50, plus 1 time x, which is 3. So 50 plus 3 is 53. So this is the type of table we should prepare to solve the sum, which makes things easy. Now let's create two equations. It's mentioned that the sum of the two digits is 5. That's one equation. And also they have mentioned that when the digits are reversed, the number is reduced by 27. That means the new number is less than the original number. The new number is 27 less than the original number. So we can say the new number is original number minus 27. The new number is equal to the original number minus 27. Get the like terms together, solve it further, and you get equation 2. And solving the two equations simultaneously, you get the two values And the final statement, the required number is 41. Now in the 14th sum, the tens digit of a 2-digit number is 3 times the unit digit. That's condition 1. So the tens digit is 3 times the units digit. So with that information, I get equation number 1. And the second condition given is that the sum of the number and the units digit is 32. That means the number, which is 10x plus y, plus the units digit, their sum is 32. So I get equation 2. Solve them simultaneously, get the values of x and y. So the number is 31. Now mark sums 8 and 12th as IMP. In the 16th sum, again 2 conditions are given, and here also they have mentioned about interchanging the digits. So whenever they talk about interchanging the digits, they should make a table, original values and the new values, or you can even say interchanged values. So we take the original number as 10x plus y. So the new number will be 10y plus x. Now according to condition number 1, they said that the 4 times the original number is 7 times the interchanged number. So open the brackets, like terms together, and you get equation number 1. And according to the second condition in the question, the difference between the digits is 4. So you may write x minus y is 4 or y minus x is 4. I'm writing x minus y is 4. That's the second equation. Solve them simultaneously, get the values, and the number is 84. Now in the 18th sum, again 2 conditions are given. There's no reverse number here, so no need to make any table. A 2-digit number is obtained by multiplying the sum of the digits by 8. So assuming that the 2-digit number is 10x plus y, the 2-digit number is the sum of the digits multiplied by 8. So open the brackets, like terms together, and you get equation 1. And the second condition says that the 2-digit number is also obtained by multiplying the difference of the digits with 14 and adding 2. So I got, on solving this, we get equation number 2. And here I'm assuming that the x is greater than y. If you do it y minus x, it's okay. So by solving simultaneously, in the end I get the number as 72. If you're getting it as 27, that's fine.